So the first thing you need to be able to do for binomial expansion is to recreate Pascal's triangle. You can do this on your calculator using the button that looks a bit like that, or something very much along those lines. You'll have to check exactly what's on your calculator, but I usually find it's easiest just to draw out the triangle. So it starts off a little bit like that and carries on, and basically each term is made up of adding the two numbers above it to get the number below. Okay, so where there isn't a number, we presume it's a 0, and each thing adds up as we go along. You should find that you get quite familiar with this if you practice enough binomial questions. And basically, the number that's second in, that's the row we're on. So this one up here would be I suppose the first row. That one's the 0th row. 2, 3, 4, 5 and so on. And the number of the row relates to what power you are trying to expand. The numbers in Pascal's triangle are the coefficients of each bit of your binomial expansion, and we'll come back to why they're useful in just a second. So say you are trying to expand something like, I don't know, the question gives you 2x plus 3 to the power of 5. You're going to need to start by working out what goes where. Now I always think it's easiest to write it out in the form of a plus b to the 5 and then substitute in your values, just to make sure that you don't get too bogged down in what the powers are and things early on. So what you do is you take the first thing, which in our case is a up here, and you start with the power that you've got and you work your way downwards. So we're going to go with a to the 5, a to the 4, a cubed. Now I'm going to have to start a new line because otherwise I'm going to run out of space, but you should have enough room. A to the 1, and we could write a to the 0, but I'm just going to put 1 because we know that a to the 0 is worth 1. So then we're going to work our way upwards with the second part, so in this case the b. So we're going to have this one here would be b to the 0, but again we're just going to put times 1. You can probably see that we don't even need that, but we'll put it anyway. Then b to the 1, b squared, b cubed, b to the 4, b to the power of 5. Okay, so that's our a and our b taken care of. We know we've sorted out all of our powers, and now what we need to do is just bung in our coefficients from Pascal's triangle as we saw before. So we're talking about the fifth row of Pascal's triangle, so you should remember hopefully that that went 1, 5, 10, 10, 5, 1. And then we can start to simplify that stuff out. So if you take this first section, you've got effectively just a to the power of 5 there. Okay, and remember we've got to put pluses in between all of these things. The second one can be written as a to the 4, b to the 1 and 5, so we'll write it as 5, a to the 4, b to the 1. And then the next one, 10 a cubed b squared. And then 10 a squared b cubed, and so on. I'll let you fill that bit in for yourself. Where this now comes in handy is where we had our 2x up here. We're going to substitute in wherever we see a, we're going to substitute in that 2x. But here's the important part, you've got to have it in a bracket, because it's not just, the common mistake is people will put that is just 2x to the 5. Like that, which it isn't. That does not work. You have to do 2 to the power of 5 as well, so when you multiply that out you're going to get 32x to the power of 5. But for now we'll just substitute. So we're going to keep on going. We've got our 5 lots of, and that's an a, so we're going to substitute in, sorry about that, 2 to the x to the power of 4, and then for b we're substituting in 3 up here. And you should be able to see, as you go along, you'll get a long complicated list of things. And at the moment we've got lots of pretty colours, but we haven't got a lot of room. So I'm going to rub out some of our pretty colours and see what happens. If I just carry on over here, in fact, let's go with purple. 2x to the 5, if we then multiply that out, you've got to do everything inside this bracket to the power of 5. So we're going to go with 32, which is 2 to the power of 5, x to the 5. This next bit, when we simplify it, we've got a 5 times by 3 times by 2 to the power of 4, and then we're going to have x to the power of 4. So 2 to the 4 is 16, and then we're going to times that by 5 and by 3, and that's what would go here, and then we're going to have x to the 4, and so on. Really, it's just, at this point, a case of just multiplying out and simplifying as you go along. Take a few lines to do it, but I still think it is easiest if you start with A's and B's, like we did up here, and then you've got a base to work from and you just substitute in. That way, if something does go horribly wrong with your powers and things, you've shown the examiner that you can do the binomial expansion, it's just that you got a bit muddled up when it came to your powers. So always worth taking this step first. So very quick recap, to multiply out this, you need the fourth row of Pascal's triangle, which goes something like that, and then you just need to start with your a to the power of 4 and work your way downwards. So we've got a to the 4, a cubed, a squared, a, and then that's going to be 1 at the end. And then we're going to use our b, and we're going to start at 0, or at b to the power of 0, which is just 1. So we don't actually need to write it here. And then we'll have b to the 1, b to the 2, b to the 3, and I'm just going to turn that 1 into a b to the 4, because timesing it by 1 makes no difference. And then we need to bung in our coefficients, so times by 1, times by 4, times by 6, times by 4, and times by 1. So when you multiply it all out, you have got your coefficients, 1, 4, 6, 4, 1, and you've got your A's go down in powers, so 4, 3, 2, 1, 0, and your B's go up in powers, so that's b to the 0, b to the 1, 2, 3, and 4. So dead simple way to work it out, and then substitute in whatever value they've given you for A's and B's. You can also use this to quite easily work out the coefficient. If it just wants the coefficient of x squared, for example, you can use that, knowing which bit is your x power and whereabouts your coefficient will appear.